This
that there's
conference will now be recorded.
it still assumes that there's a BMC functionality in each of the servers, but it they also have a separate function that's actually integrated into their PMDU, their power management solution, that aggregates the rack management functions, as well as provides some rack level um, telemetry for power consumption, power, and some control functions. So it does um, some power control and an aggregation of telemetry information coming off of the rack, and and so that product and that source is, like I said, it's been open sourced for about a year, and it's built into the Microsoft Olympus product. Subsequent to that, there was um, work going on at Inspur, and it actually dates back several years with the work that Inspur did for ODCC to build a rack management solution in the ODCC rack. And that rack actually has a pretty sophisticated rack management solution that performs the same types of functions that Microsoft is doing with Olympus. Now, it turns out that the ODCC approach was to actually build a separate controller that sits in the rack outside of all the server nodes. And the software that ran on it was a licensed software from one of the firmware companies. And Inspur had started working towards a open source solution that replicated this rack management function. And they've discussed that option with myself for the last, I don't know, 6 months or so. And I encouraged them to work towards a rack management solution that would work for specifically for open rack, but really for any type of full rack deployment, and be able to support any ingredient that goes into the rack, as well as ingredients from any supplier. And given that we have already headed down a path to standardize on the Redfish protocol coming from storage and servers, it made sense that now we actually have a way to talk to this aggregator and have a common language between the aggregator and the nodes, and present a single IP address for the rack to manage the resources. And so with that in mind, I had conversations with Brian Kelly. Brian is online and runs the firmware group at Microsoft, and talked to Sai Desari at Facebook, and Sai's involved in firmware development at Microsoft. I'm sorry, at Facebook. And then obviously talk to the Inspur team, and Alfie's on the line there, as well as another probably half a dozen other companies that have RMC-like functions embedded in their product. One of those is a recent product that's going through the contribution product. It's an Edge server from Nokia, and they actually have a RMC function that provides basically the same thing. I also spoke with 2C RSI at the Amsterdam Summit, and they have a similar type of rack controller, and they use that for controlling the fans that they mount on the back of the open rack. So it was clear to me that there's an opportunity for us to collaborate on this effort, and put together an open source base that we can all pull from for products and upstream different development. So I just threw together a couple of slides, and some of it some of it is slides I created, some of it came from Inspur, some of it came from actually the the original Olympus presentation that was done a year and a half ago. And that was a presentation done at I think it was the 2017 summit. So let me just go through that real quickly. But basically what Olympus envisioned, and I think this is consistent with with everybody that I've talked to, is that you have this piece of hardware that provides this rack management function, and on the right hand side are the actual devices. So these would be a compute node, a storage node, a GPU solution, and on the left is your fabric, or your data center information system. Um, and so that data center information system or orchestration software, talks to the rack manager through standard industry APIs like Redfish or Swordfish for storage. It also provides a RESTful interface and an SSH interface, and potentially you can actually just attach to the RMC through a web GUI. On the southbound side, the rack manager is able to talk to all of the devices, again, through the same Redfish or Swordfish API. But in addition to that, it's possible that you could also take advantage of, I'll say, some lower level protocols like IPMI or I2C connections. And this is how Olympus did that when it was integrated into the PMDU. And so that's kind of a diagram on how Rack Manager fits. By the way, I'll pause right here. I know Brian's on the line, and I'll give him a chance to correct me if I've said anything incorrect at this point.
That is correct, Bill. We developed the Rack Manager to do a few things for us. One was we used it as a point of aggregation for managing racks as opposed to individual nodes. And the protocols behind it are in fact IPMI, Redfish, SSH, there's SFTP, TFTP, and a couple of other transfer protocols that we use for moving data in and out of the BMCs on blades in the rack. We also use the Rack Manager for PDU management or power control of the rack and the server devices. And then we also use it as a power meter for the rack to give us back some telemetry, and it's used in optimizing the power provisioning of the rack. It has some signals that go down through it, out through the PMDU and to the servers to keep the servers under a certain rack power limit.
Yeah, so the slide I'm showing right now, again, is actually a slide that came from that 2017 presentation at the summit. But it kind of indicates, like Brian said, that there's interface to the AC power supplies, and again provides some power capping type functionality. And I think that's consistent with other implementations, whether it's the Open Edge or the ODCC rack. There was some opportunity to do power capping when you have connections into the power supplies. And so what I did is basically took that Olympus concept and said, actually that concept could be implemented across, a couple different rack configurations. One of those, I'll just look at the left-hand side, the open rack. And again, given that the hardware that you actually host this RMC function is basically a BMC device. It could be a small ARM device. It could be just any type of embedded controller that runs Linux. Is that functionality can be embedded into either an additional component that goes into the rack, you're integrated with an existing component. So in the left-hand diagram, basically showing that it's possible that this RMC functionality could be built into the power shelf. And in fact, the power shelf from Schneider and others has a BMC built into it that does some of that today. And so with the right connectivity through the top of rack switch, it would be possible to integrate that into that power shelf. And since we have power shelves in every open rack solution, you could basically get this functionality for no incremental hardware cost. The middle diagram is another example of how this could be implemented. But again, given that switches have a BMC, BMC is adequate for hosting this RMC function. You could build that into the switch RMC and provide the same level of rack level control. And actually, you could still connect the power shelf into that switch as well. And then the diagram on the right is the Olympus configuration. So
Brian?
Again, yeah, go ahead. Was there a question?
Yeah, question. So in this architecture, is there additional extensions for removing single point of failure? Because all these have only one RMC. So is dual RMCs also part of the architecture?
So, John, this is I don't think this is a good architecture slide because it doesn't take any
no,
of.
No, that's why I was asking Brian whether what came out of Olympus
I
actually
can
dealt
tell
with
you that. Yeah, I believe that within Olympus that there's provisions for to eliminate single point of failures that you can boot off of or do resets off of adjacent racks. And I think that's the same with the ODCC rack. So there's a lot of detail that's not in this concept, John.
Okay.
But let me jump down to this slide 6. So this slide is kind of architecturally from a software perspective, how Microsoft builds their rack manager. And I think the thing to take away from this is that if you look at Yocto down and you look at the BSP and U-boot and kernel and applications and services, this looks exactly like OpenBMC. And so there's a ton of commonality there. And then obviously you have applications that run on top of Yocto or on top of Linux that build up that functionality. And it turns out that in some of the initial concepts from Inspur, this was exactly the same model. And again, this came from the Inspur firmware team, but they envisioned a very similar type of implementation. So if you look at the D-bus down, this is exactly how OpenBMC is constructed, and they're building applications and envision that applications would have to sit on top of Yocto or on top of the OpenBMC base firmware base functionality. And so this becomes a set of applications that provide your northbound API interface as well as the functionality for aggregating the information. It could also provide rack level functionality, whether it be things like power capping or you could integrate some of the Intel RSD functions in at this layer, this application layer. You can do fan speed control and so on, but those are all applications written on top of that. And so at that point, I realized that architecturally, there was a lot of alignment between what Inspur wanted to do and what Microsoft had already done. and so it made sense to go ahead and try to actually build a project around that. So I think that was the last slide that I wanted to share today. Let me go quickly look through this. Yeah, a lot of these other slides I have in here actually came right out of the slide decks from that Microsoft presented at the summit, so you can pull those up. But anyway, Mike, the Inspur team is interested in putting together a project to build an open source RMC solution. Brian Kelly from Microsoft obviously is Microsoft's already open sourced that. They're willing to give us a refresh of that code, so we have a current snapshot of that code, and you can use that as the basis to build upon. I believe that it is consistent with the direction that the hardware management team is going and the adoption of redfish and swordfish. I believe that from a product portfolio perspective, that it gives us a path to have orchestration software be able to talk to the RMC and be able to manage and have a management solution for all the rack hardware, which is something that we don't have today. And the beauty about this is that if we can implement this vision, we would have a similar management solution for OpenRack, for EIA racks, or Olympus. So if you're a software developer and you're writing orchestration software, regardless of the underlying hardware, rack level hardware, you have a pretty similar API that you're talking to through the RMC. The other thing that I envision for this is that and I'll use this slide here, but if you look at the yellow boxes on this slide, on this Inspur firmware stack, these are all applications that run on top, that would run along with the OpenBMC applications, and it's quite possible that eventually, if we developed a robust solution, a working solution, that we could actually integrate these applications into a BMC, and this functionality then could coexist with BMC firmware that is embedded in a switch, or embedded in a power shelf, or for that matter, embedded in a actual compute node that was also serving as a rack manager. So there's a couple of different options there. So that's what I envisioned for or as an opportunity to collaborate on some open source firmware. I'll pause there and let folks ask some questions.
So would that final software base be owned by OCP?
Yeah, well, so John, what I envision is that we would actually create a source tree. We would start off with ideally start with the source base that Microsoft has used for the Olympus, and because that is built off of Yocto, that it should look a lot like OpenBMC, so there's certainly a familiarity there. And then ideally let all of us, or any company that wants to work on this, participate, and and for example, Inspur, and build upon that source base this application layer. And that the idea is that we have one source base, that these different applications are upstreamed, or different, as people develop their code, they upstream it into this one source base, and it allows us to then have a single repository that we can build, an RMC product off of. It would. I also envision that it would give the hardware management team an opportunity to kind of define the required properties that should be supported from a northbound perspective, because I think the southbound would be the same properties that we already have. And obviously, John, I would look to the hardware management team to, kind of steer this in the right direction.
So this would be a subgroup under the hardware management project?
I think that's a good question. That would be certainly one place to host it. Again, I'd kind of look for John's input on that.
Well, I think that's a good place to have it. I don't see any other project which could house it. Rack and Power could, but they're more interested in the endpoints of where the telemetry actually comes from, not the aggregation part of it, which is all management work.
So let me ask Alfie: have I represented INSPER's intentions correctly, and have I kind of represented the ideas that we talked about correctly?
Yeah, pretty much. And I think also, echoing John's sentiment is that the RMC actually falls within the scope of the hardware management project team. One of the things that I would like to talk about is just the on the hardware side, right? So there's several implementation right now on the market from Microsoft, from Nokia, and us. And now, do we want to or look at standardizing the or is there any motivation to standardize the hardware design and hardware implementation? Or is it that everybody is free to build their own, so long as it is capable of exposing a defined set of profiles or hardware profiles of the underlying components that it manages.
Well, I would think the profile would define conformance of the interface, but it would not define implementation. And the way OCP normally deals with implementation is that any member company can submit a design, which gets accepted, and then people release products against those designs. So if we define the interface, then now it's up to each individual company who wants to submit their quote design to get that through OCP, and then products will follow. Right. So I think that process is well understood within OCP. Once you design what the design should be, so the design would have conformance to the interface, and then whatever form factor is needed. So you may have a design for each one of these, right? You may have a design for a standalone. You may have a design for if it's embedded in a power shelf, and you may have a design if it's embedded in a switch.
Yeah, I agree. It kind of depends on the implementation. It's going to dictate the actual, hardware and where it resides. And obviously, Microsoft has been working on this for years, and they're they change they're doing. As new people get involved in the project, obviously there's reasons that they would like to leverage whatever's been done previously, and so there's an opportunity for kind of, I'll say, new entrants to standardize on hardware implementation. And I can actually see, Alfie, I can see where it may make sense if there's like a standalone, RMC box. I'll just call it a black box that provides that functionality that, you know, there there's not a lot of value in the hardware. And so it's, that may make sense to, just have that piece of hardware, shared by, a lot of different consumers,
Yeah,
developers.
the approach we took on the rack management was to standardize the northbound interface and the APIs from the northbound interface so that when it came to fabric integration and everything fabric bound, that interface was discoverable, and there was known or predefined functionality that is known to be there. And then the southbound interface and the protocol and the APIs that could vary to some degree from hardware to hardware based on what features they had, based on what protocol they spoke. So it created this abstraction to the underlying servers that enable us to uniformly manage them at a rack level, irrespective of the generation or the type or the supplier. We had this abstraction layer that, we call this specific API. We know it's going to perform a certain functionality on the back end. And I think getting to that gives you the best of both worlds. You get to have a lot of innovation at the hardware and device level, while you still don't lose this rapid integration, or quick to adapt at the rack level.
Yeah, and I'm just showing you the original block diagram from the Microsoft Rack Manager, and I think this articulates, or is a good example what Brian was talking about, how on the southbound side, there's just a ton of GPIOs and A to D converters and UARTs that allow you to do just a ton of different things, but they standardized on the northbound side. And so, and I actually think that the Rack Manager, I actually believe is open source. So somebody could start with those schematics, but I don't think it matters really whether or not we standardize on the hardware. I think at some point it makes sense that you probably need to have one or two controllers that you standardize on, just to make it easier to build with Yocto. But that's probably the extent of the standardization.
And at that point, we might actually go to the Rack and Power project and say, do you want to standardize the Rack Manager hardware?
Right. And obviously, if you're Schneider and you have this power shelf that has a slot already dedicated for RMC or BMC functionality, that it makes sense to integrate into that, right? And so they may already have all of the hardware necessary, and it's just a matter of taking that application software and building it on top of their BMC firmware.
Just a quick question on this northbound interfaces. So are we thinking of the northbound interface, or is there any competing standard?
Alfie, we're having a hard time hearing you.
As not me, as somebody else. Yeah, I couldn't make out what was said.
Hi, Bill. This is Sai.
Oh, hi, Sai. Yeah, we're having a hard time hearing you.
Oh, okay. I think the signal is bad in this place. Maybe I'll send the email later.
Oh, that's okay. Go ahead. That's better.
Yeah. I think I was asking about the northbound interface. Is that going to be Redfish, or is there any other standard you think we should define?
Um,
From
This is
our perspective, we defined the northbound interface as Redfish, for the most part. Obviously, that interface doesn't land well to file transfer and serial console. So it's also got SSH. It's got a CLI, and then it has HTTPS, TFTP, SFTP for file transferring. But I think Redfish is a standard is still somewhat evolving. It won't cover all devices in the rack, but it's definitely a good baseline.
okay. I think I'm trying to understand the scope of this project. So one is like the northbound interfaces. I think we should align on that. And then I heard that there is no standardization for the hardware itself, right? Because there is different architectures.
Well, the architectures and the hardware to me are two different things when you look at hardware selection and then rack level architecture. So does hardware mean choice of SoC or controller, or does hardware mean the form factor?
I meant both. Like say in your case, you are using Texas Instruments
Yes.
SoC. Right?
Yes,
So
we chose, we chose Texas Instruments, the TI chip for rack management, mostly due to security, and stability. When when we looked at repurposing some other controllers that we use, they just didn't meet the security requirements that we had in mind when we set out on designing the rack manager. So then we looked at processors that were shipping in high volume and had some stability, and also had that 10-year lifetime kind of support. When we put in rack infrastructure, we typically look at the rack infrastructure being a 5+ year infrastructure investment, as opposed to servers where you might decommission them in a shorter period of time. So when looking at longevity and security for rack management infrastructure, it took us away from BMC type SoCs. And then we looked at stuff that's going to be appropriate for the functionality of a rack manager, like power management, and having those high accuracy A to D converters. That brought us to conclusion. There was a couple of chips we shortlisted, but eventually we decided on the TI chip that we chose for the rack manager. And it is Yocto based, and there's a full open source BSP there. We added to the BSP in the process, but it's that too is open sourced.
okay.
So,
Is there
I think the more important question though is that it doesn't, in terms of the scope of the project, I don't envision that the scope would tie to a specific hardware implementation. I think the scope has to include, let's say the AST 2400, 2500 part. And it may include other microcontrollers, right? I think we have to include that in the scope, or allow choices to be made, again, based on kind of the target implementation.
Absolutely. I would agree with that.
Yeah, I think I don't disagree. I was asking like the scope would be to share the northbound interfaces or even the implementation. So once it comes to implementation, So then that's where the real hardware details matter.
Right. And I thought I had mentioned that when that point comes and someone wants to actually contribute to design, that design would go through rack and power.
Yeah. So in terms of the hardware design, John, yeah, that would certainly, go through that particular group in terms of a hardware contribution.
So what will be the deliverable for this open RMC subgroup, like as a group, if we form this subgroup under hardware management? The scope and deliverable for that will be the northbound spec, the profile.
Yes.
Well,
I would think, Sai, I think that's the northbound interface is a critical component for interoperability, for sure. So I think that spec would have to be, one of the deliverables. I think you would also, to help device manufacturers come out with some southbound spec. I don't think everyone is going to want to contribute to the rack manager source for their device to be able to interoperate with it. So I think you have to come out with a southbound specification, and then anything that's in addition to that or outside of that, then people get into contributing to the rack manager source to make that work.
Yeah, southbound, I have questions actually, because southbound means if you have a dedicated RMC, you have a set of southbound interfaces. But if it is part of PowerShell, or if it is just part of BMC firmware on the rack manager, those three shell models, the southbound does not, there is no uniform southbound interfaces in that case.
The implementation doesn't need to be uniform, but there may be specific functionality that you need. So if you have a northbound functionality that requires that each southbound entity be able to behave in a certain manner, then you need to be able to specify that. But how that southbound entity wants to expose it through via what interface is an implementation issue.
Oh.
Okay.
So right now with the OCP profiles, right, we've got a pretty low bar. What doing RMC would do is say, hey, I've got a northbound capability, which in order to process it correctly through the RMC, I'm going to have to impose these requirements on the southbound OCP platform, which plugs up to this. And that's one way of kind of raising the bar on the OCP platforms, is that if they want to participate with the RMC, there are additional functionalities beyond the baseline that they have to support.
So we want to bring that southbound into the scope of this project.
Yeah, it'll be southbound requirements.
Yeah. So we would like to kind of, I'm just trying to understand. Again, I'm not asking questions.
I understand. That's why I'm kind of working through it myself, saying what byproducts we're going to get out of this thing.
Yeah, what is the result of this whole? One is definitely RMC profile. Definitely makes sense from Redfish point of view. What next? Like on the southbound, I'm just debating what is the right deliverable for this group should be.
So I think there's three deliverables. One is the northbound API definition. The other is the southbound API definition. And the third is a common code base for the application.
Common code base means we are using common hardware, right? Or only the application, like one specific dbus application. Is that the common code?
No. I think common code will be more than just a dbus application. So Sai, on on the north and southbound implementations or those APIs, let me try to explain the problem and then how we solve it, right? So there's the northbound interface that our fabric integrates with, and it expects every system that it's going to control, it expects to have certain functionality. Let's just take a base functionality of power on and power off. Okay. So when our fabric comes along and talks to rack management, it says power off server 1, power on server 1. So for an Olympus design server, that's very simple for us to tie that functionality to the rack manager. And we've done it in a few methods because we've got a variety of products. Some are Redfish, some are IPMI based. So for Redfish, it's relatively simple because that interface we made discoverable. So the rack manager can discover the interface and power on and off the device. For IPMI, the interface is not so discoverable. So it has to be kind of hard coded in there, a conversion from Redfish to IPMI. Now, all of that is fine for Olympus 2-socket servers. But then we do have a portion of our fleet that's 4-socket and greater servers. So we don't make as much investment in the design of those systems because there's not as many. So then when somebody tries to sell us their 4-socket Olympus derivative, we don't necessarily have to talk to them about the details of how the BMC is going to work and functionality. We have a rack manager that's open source they can go and look at. And then we have a southbound interface that if you conform with that, you tie it to the rack manager seamlessly. If you don't conform to that, you have to make sure you bind the functionality through the rack manager so that you conform to it when these APIs are called on, off, and blink LED, all the usual stuff. Now, what happens when folks are trying to sell you OCP hardware and their management is all very different? What do you do in those scenarios? You just don't consume it, or you make them redesign the firmware. Redesigning is going to slow you down. Rack management and providing that abstraction has benefits in that you can uniformly manage systems of different types. So it allows you to adopt OCP hardware quicker.
Yeah, but isn't that what we are trying to solve with OCP profiles? Like a server, for example, if it wants to go into the rack, it has northbound interfaces. Again, this could be from server.
Yeah, it does. But what if that northbound interface from the BMC itself is a HP idle? Does HP have to go and implement OpenBMC for it to work in your environment?
Not needed. As long as it complies to Redfish OCP compute profile, you should have access to all those APIs.
I see. So Redfish compute profile is fine for a simple 2-socket server, but what if it's a GPU chassis with 8 GPUs and a bunch of PCIe slots and no host CPU socket, and it's not something that's defined in Redfish? How do you make that work?
Non-question, I think.
Then we should go fix Redfish to be able to describe it.
I think that's going to be a longer path in trying to make Redfish describe that. If you've worked with the DMTF, certainly a long haul.
I don't think so. So since I do work in the DMTF, you tell me where the gap is, and because I think that's already described within Redfish.
So we left the DMTF for these same reasons. It's not fast moving, it's slow. It's unlike OCP in these methods, in that we can move quicker and drive the results that we want. A lot of these forums are in there politically, not necessarily doing the right thing, but doing the thing that your competitor can't do.
I'm not prepared to have a political discussion about the MTF here.
Okay, well, hey, so I think our goals are the common though. We want to present a managed solution for OCP hardware that works across different rack architectures and make it easier to consume a managed solution. And by the way, this was the reason we're all on the phone today is that we have a common interest in rack management. And my goal is to get us having these conversations and thrash out some of these details. If I look back at the OpenBMC project, there's tremendous interest and effort behind it, but the parties that are involved in it got together years after they started work on OpenBMC, and their implementations are, some are very similar and some are quite different, and the differences have actually caused the program and the project to slow to some degree because of those differences. My goal today is to have us start these conversations and thrash out, common ground and common decisions, and so that we don't end up with a lot of differences. So I appreciate the discussion. I think we need to do is kind of decide, is this something that you want to commit resources to do because you share the same vision? And if that's the case, then we go ahead and kick off an effort and start working through some of these details.
So I think from Microsoft perspective, this is something we would contribute to moving forward, this effort. We're in the business of rack management, and the rack management architecture blends well to how we manage our infrastructure. We think rack scale is very much the now. As opposed, I was going to say the future, but it's very much in the now. For operating at scale, we will be continuing down the path of rack management, definitely in the foreseeable future. So it's something that we'll continue to support. So we definitely support the effort. We'll continue to open source our investments in that area. If there is a standardization effort, we would commit to being a part of it.
Okay, thanks, Brian. Alfie, are you or Rhonda Inspur?
Yeah, same here from Inspur. One of the OEM or ODM vendors that we want to commit to open standard, because we're serving the mass market, and then we want to standardize on some of the implementations that would make everybody's life easier. So definitely Inspur is in this.
Okay. Sai, do you know, what's your take on it at this point, Sai?
So in Facebook rack, the ORV2, so what we have is the rack manager functionality is built into the switch, the wedge switch on the top. So the contributions wise or the scope wise, I'm very interested in the northbound interfaces, the rack profile, maybe RMC profile, and the software pieces, the applications probably we'll be integrating into the wedge functionality. I mean, we don't have any dedicated hardware. So I'll be definitely looking forward to the discussions, but the implementation or adoption would be limited to the software pieces, not any hardware or hardware design.
Right. And by the way, I think that's consistent, that we want to make sure that it works for, the top of rack switches and wedge-like hardware. So that, I think that's consistent in terms of implementation or hardware implementation, which, by the way, I shared this kind of view with Aaron, and he too agrees that this is from a a scope perspective, this was very consistent with what he envisioned Facebook would like to do. So.
Awesome.
And then let me ask Craig White. You know what? And again, Craig, I've talked to some of the product marketing folks from Nokia, and I got the impression that this is certainly of interest to the Nokia team.
Let's see if I can get it off of mute. I think you can hear me now, right? Yeah. So I think it's definitely of interest, and I think that the it's a little more ambitious than what's required for the open edge. But I think in terms of like the open rack equipment, it's certainly in line with some of the ideas that we've had about the manageability of that. And obviously a trimmed down version of that would work well with the open edge.
Yeah. By the way, I see the open edge implementation being very similar to what Facebook is doing by integrating this in with Wedge. So I think that's
right.
Yeah.
Yeah, I mean, basically, it really just provides a pass through for the IPMI, the BMCs on each of the server boards to be able to reach, without having to have a cable, and then to control and report on power. So it's a little more simple than full-blown RMC, but that I don't think that's we're still interested, obviously.
Okay.
And even more in a full-blown implementation for the larger systems. I mean, we're certainly interested in the full open rack systems that we offer as well as part of our solution.
So I think that the next step here is we probably need to go ahead and schedule some meetings on a regular basis, and we probably need to identify a few other folks. So John, I know that you're on the phone today. We probably need to figure out, is there a firmware engineer, maybe it's James Mann or somebody else that would like to be a part of this from Intel. And then my request from all of you is there others that you know of that we should be reaching out to, and having those, and including them. We certainly don't have to answer that today, but keep that in mind that we need to figure out who our other stakeholders are on this journey.
Right. So are the next steps to do a charter, or is it just to start formulating architect documents, drafts?
Well, good question. Oh, go ahead. I was going to say I actually started I think I did. Did I start a rough draft charter on this? I may have. I don't remember. But I think that we can do we can put together a charter and scoping document, as well as start looking at what we different work streams, and start maybe identify folks that want to work on let's say an architecture overview.
Okay.
I guess, Bill, we can set up a small subgroup and kind of invite everybody that we think we want to, like to CRSI and others, right, to the subgroup. My question is, I know that it's going to have a house under the hardware management project. Do we have anybody that wants to steer this effort moving forward, from the group here? I need somebody to take a helm a little bit in consolidating everybody's inputs and, figuring out the charter.
So I don't have a problem taking lead position on this if you need that.
somebody from Inspur that would, that'd be willing to, kind of run this.
Sure.
And by the way, I'm happy to have Brian involved in it or Cy, but I know that you guys are, scattered across a couple other OCP projects. So I'm just thinking that, maybe this is a great opportunity for, somebody at Inspur to get involved in kind of leading this effort.
Yeah, I think so too. And from us, Bill, I probably won't be that active in this one, but Sriram from my team, he'll be the active participant from Microsoft.
Okay.
Cool. All right, so let's set up a small subgroup here. Would this time work for everybody moving forward? Like Tuesday, 9:30 Pacific?
Fine with me.
Okay. Well, why don't we tentatively set it up as a placeholder until people can, in the community itself can decide whether this works moving forward or not. John and Alfie, do you guys get back together in a week, or do you want to get back together in 2 weeks?
Probably in a couple of weeks would be okay.
Okay. So 2 weeks from now will be the starting point, and in the meantime, we'll get the word out to everybody that we are forming an open RMC subgroup under the Hardware Management Project. Sound good?
And so is there a deliverable in 2 weeks?
There's no deliverable. I think you guys will have to figure out, what the charter will be from the larger community, I think.
Okay.
And then, as you guys progress forward, decide how you want to proceed with all the members, right? I don't think that there's an expectation that that there will be a deliverable in 2 weeks, John.
Okay, just want to set my expectations.
Yes, I think
There's one other action I think we should take in the next 2 weeks, and that is I'd like to see Rajiv, reach out and just have some one-on-ones with, let's say, Brian, Kelly, or whoever he assigns to it, Alfie and maybe Cy, and just understand, if we start to structure a GitHub project, how would we structure that?
Right, Bill, you're spot on. I was thinking along the same lines, and yes, I will get in touch with the key stakeholders to get more information on what their thoughts are.
Yeah,
because the end goal is to have it, unified, GitHub framework for this open RMC project.
Right. So again, just try to understand, what our options are, what's the best way to approach it, and then what makes sense to, and also keep in mind is that at some point, how would we work with the Open BMC groups also too. So anyway, I think that's also.
Okay, so we meet back in 2 weeks. We'll set up a call, a series of calls to meet every 2 weeks. We'll, in the meantime, send out a note to everybody in the community, letting them know that there's a new project underway. If they want to participate, to join the call. And for the time being, I have John Lear listed as well as Alfie listed as leads on this project.
All right, sounds good.
Thank you.
Thank you so much, everyone. Really appreciate the time.
Further. All right, thank you.
Just
to
thank you.
All right, bye.